Okay, so in the notes today, it says we're on section 4.3, number 1, the definite integral as the area of a region. So if we have a function that is continuous and non-negative over the closed interval from A to B, then the area of the region bounded by the graph of f is our function, the x-axis, and the vertical lines from x equals A to x equals B, is given by this right here. Right here, that formula is going to be what we're going to use to find area. So we're going to sketch the corresponding regions to start with. So what this tells us then is that the area is what we are finding when we evaluate this integral. So it says again that we are bounded by the graph of f. Y equals, what is our function? Y equals 4. So that's our function, y equals 4. Our a value is going to be the line x equals 2. Our b value is going to be the line x equals 5. So now I'm going to draw a picture of what they're talking about here. So we're graphing the line y equals 4, just like that. We are bounded by the x equals 2, which is the vertical line right here, by x equals 5, which is the vertical line right here. So we're bounded by all of these things. We're bounded by the curve itself, which in this case is a line, x equals 2, x equals 5, and the x-axis. That's what that says. So this would be the area that we're talking about. You should notice that that's exactly the same area that we talked about over here. So for that problem, we could find that area simply by doing base times height. 3 times 4 is 12. That means the answer to this integral would be 12. But we're not going to get into doing this with the integration methods yet. We're just going to be drawing some pictures to start. So looking at letter B, identify your function. The function is negative x plus 3. Hello? So go ahead and draw that, you guys. Yeah. Nope. Nope. Okay. Okay, so we got that. And now we're going to plug in, you should know how to graph this. This is a line, right? It has a y-intercept of 3. We have to go down 1 over 1, down 1 over 1. So this is going to be this line right here. That's the line that we're graphing. We have to be bounded on the left by the line x equals 0, on the right by x equals 3. So the region that we're talking about is this region right here. That's what that integral would find, is the area of that region. On letter C, our function is y equals the square root of 16 minus x squared. Does anyone know what kind of shape that is? What kind of shape is y equals radical 16 minus x squared? Anybody knows? All right, well, let's do this then. If you have y equals radical 16 minus x squared, I can square both sides. I get y squared equals 16 minus x squared. I add x squared. X squared plus y squared equals 16. Would you know what kind of shape that is? Circle. But if I go back and solve this, y squared equals 16 minus x squared, I take the square root of both sides. Y equals plus or minus the square root of 16x squared. So a circle has to be y equals plus or minus this. We only have the positive. So what do you think the shape's going to be then? Not a full circle, but a semicircle, right? So this would be represented by the semicircle that has a radius of 4. Look like that. And then it's bounded on the left by negative 4. On the right by positive 4, which I don't even have to draw. It's also bounded by the x-axis, and so this would be the area that that would find. So if we were to do that integration problem, that would be the area that would be found. All right, let's come down now to example 2. We're going to go in the other direction now. It says to set up a definite integral that yields the area of the region. Well, we know the area is going to have to equal the integral. Now, we have to know what numbers go on here. So I have to know what's it bounded by on the left and what's it bounded by on the right. So I'm going to take the function and set it equal to 0. So I get x squared equals 9. So what must those points be then? -3 and +3, right? Then I write down what is the function. Now there's one little thing that's missing. Does anyone know what else would have to be written on there? What is it that's missing? dx, right? You have to have the dx. Anytime you're doing an integration problem, that tells us what variable we're integrating with respect to. So that's the way that would look. On letter B, to find this area, it's going to be equal to the integral. Again, we would set this equal to 0. I bring over the absolute value of x. What would x be? For the absolute value to be equal to 3, what would the x value have to be? +3 or -3, right? So we put the leftmost one goes on the bottom, the highest one goes on top, right? And so now we're going to have to write our actual function in here. And then what else do we have to put? dx. Okay? So when you get into college level calculus, and it's going to go quickly, much faster than what we do in here. What we do in here is equivalent to 1 semester of college calculus. So like around probably October next year, you'll be seeing things like this. Luckily you'll have seen it before and you'll be able to think, oh, that's just the area of the curve. Okay? So it's nothing mysterious, looks complicated, but it's really not. Okay, let's look down at some properties. The first property says the integral from a to a of f of x dx is going to be 0. Can anybody explain why that would be true? Why would it be 0 if it's finding the area? Paige? Say it again. Yeah, it is. It's saying that we're going to start at A and end at A. So if A is right here, if I'm going to start here and end here, what's the area? There's nothing there, is there? So that's why that's going to have 0 for the area. For number 2, we're going from A to B. This says that if we want to go from B to A, then all we have to do is put a negative in front of the sign, in front of the integral symbol. And that has to do with the order that integration is done in, which we'll get to later, but you have to know that property. This next property says that, let's say we have some function, maybe it looks like this, and we're trying to find the area from A to B, but there's a point C in here. This is just saying then that I could do the area from A to C plus the area from C to B, and I could still get that answer, instead of doing it all at one time. The next property says if I have a coefficient, I can pull it out in front. Number 5 says that if I have 2 functions inside of there, I can simply split them apart. So now we're going to apply those formulas. So look at example 3. So we're going to be given this information. The integral from 1 to 3 of x squared is 26/3. The integral from 1 to 3 of x dx is 4. The integral from 1 to 3 dx is 2. So what we're going to be doing is evaluating these by using these values. So for letter A, I'm going to pull the 12 out in front. Anytime I have a coefficient, I should pull it out in front. And so now I look at my rules right here. What's that equal to? Match it up. 1 to 3 dx is equal to 2. So this answer then would just be 12 times 2, which is 24. On the next one, I'm going to pull out that coefficient. So what about this then? What's that equal to? 4. So it's going to be negative 3 times 4. So it's going to be negative 12. On the next one, I'm going to pull out the 4, so now I have 8. Now, the other problem, though, is even once I pull out the 4, I've got the x dx, which matches here, but this is going from 3 to 1 instead of from 1 to 3 like I needed to. So if I'm going to make it go from 1 to 3, what am I going to have to put out in front? A negative sign. And then we have x dx. So now we're going to have negative 8 times, we look for this answer, from 1 to 3 of x dx, that's 4. So it's negative 32. The last one, guys, this one people kind of struggle with. We have two functions. So we're going to have the integral from 1 to 3 of x squared dx plus the integral from 1 to 3 of just 1 dx. If it's a 1, I don't even have to write it. But it still has a value to it. So what's the answer to this right here? 26 over 3, right? Plus, and then what's the answer to this? 2, so I'm going to have to add on 2, which is 6 over 3. So 26 over 3 plus 6 over 3 is 32 thirds. And that's going to be our answer. Any questions over that? Okay, so you have your homework up there. Or it's on the board and on your assignment sheet. Let's also go ahead and get out your homework.